Welcome to SmokeGuard's AIA Continuing Education series. Today's AIA course is titled Fire and Smoke Requirements for Openings in Rated Walls. This course has been approved for one learning unit for health, safety, and welfare with the American Institute of Architects. SmokeGuard is part of the Engineered Building Solutions Group, a segment of CSW Industrials. The EBS Group unites Balco, Metacock, SmokeGuard, and Greco. These four leading brands provide innovative, safety-focused solutions for architects, building owners, engineers, and contractors with a shared commitment to life safety by design. SmokeGuard offers flexible, visually appealing fire and smoke protection systems designed to cover everything from small openings to large atrium spaces. SmokeGuard offers a full line of elevator smoke containment systems, including vertical, horizontal, and perimeter fire and smoke curtains, as well as shutter and static curtain solutions. SmokeGuard is a registered provider with the American Institute of Architects CES program. This course is approved and in compliance with AIA. This program is not intended to promote any specific construction material or method of use. At the completion of this video course, you will need to take our 10-question test and get 70% correct to receive your AIA Certificate of Completion. You will receive your certificate via email. If you are an AIA member and you provided your member number, we will report your course completion to AIA for credit. Please allow for up to 10 business days to report credit to AIA. This presentation is copyrighted by SmokeGuard. Any reproduction, distribution, display, or use is prohibited without written permission. In this course, you'll gain a foundational understanding of the 5 main types of rated walls, their typical applications in various building scenarios, and the standards that govern permissible openings. We'll also explore common design challenges across different occupancies and highlight high liability mistakes to avoid during specification and construction. This presentation was pre-recorded by David Bauer. David is the Architectural Director for SmokeGuard. With that, let's turn it over to David.
So the types of rated walls, as defined by the IBC, there are 5 of them. We, of course, have non-rated walls. In addition to that, you can do anything you want with that. We have firewalls, fire barriers. You see what they are. You've probably worked with every one of these. Firewalls, we'll talk in a moment about where we apply these, but they have different criteria. The first 4 of these are fire rated, and the last 3 of these are smoke rated. It doesn't come into play as much in the type of wall that we're looking at. For example, you could have a 1-hour fire barrier and a 1-hour smoke barrier, and you could use the exact same UL assembly to construct both of those. So that part of it's easy. It's when you get to the openings that things really change. So then you can have a non-smoke rated door and a fire barrier, but you cannot do that in a smoke barrier. So the ratings change, the fire endurance time of them change, and a lot of things change in the opening. So whereas the wall itself is a pretty basic thing, the openings is where things really change. That's where the meat and potatoes of this is. So just the big picture on openings, on the first 2 of these, you're limited to 25% openings. And on the fire partitions, smoke barriers, and smoke partitions, ironically, the 3 smoke rated ones, you're unlimited in terms of your opening size. So that's expressed as a percentage of the overall wall. So firewalls, for example, you're limited to 25%, depends on how long the wall is, how many openings you can have. And that is an aggregate of the total width. So let's look at some of these in greater detail. We'll start with firewalls. And this one, as we know, is fire rated. It is not smoke rated. So you have no S labels, nothing like that in this one. They come in various ratings, 2 to 4 hours. There is no smoke requirement at all in either the wall or the openings. And the standard, you're going to see this a couple times, ASTM E119 and NFPA 263. Those are, actually, I think it's a typo. I think it's UL 263. But you're going to see those recurrently in here. It is a standard by which they describe how you test a floor slab, a roof slab, a wall, non-bearing wall, or column. Any of those 5 principal building elements are all defined within ASTM E119, but that is for a structural component of the building. That is not for the opening. So where are we going to see firewalls? If we do a new building and we've already exceeded our maximum allowable area for the building, yet we still need this to satisfy the performer requirements of the owner. We have to increase the building size to what he needs, but we've already hit our maximum. based on that construction type, occupancy type, and all the parameters that are in play with regard to the building that we're building. So we want to create additional area beyond that. We can construct a firewall to separate that additional area. If we do that, we've effectively created another building. So the egress calculations, everything is calculated as a separate entity on either side of that firewall. A very similar application is if we have an existing building already and we want to put an addition on it, similar thing, kind of a parallel calculation. We might want to put a firewall there to separate the new construction. We would do this for a bunch of reasons. One is we may want to do that just so that we can exceed our occupancy like we did before. We might want to have a completely independent calculation for our egress scheme. We might have different construction type. A lot of things might change. So we're kind of free and clear to do that in a whole new way in the proposed addition. Other type of wall that is very, very common, it's hard to visualize a building without fire barriers in it. They're almost always there. Maybe the simplest of slab on grade buildings, you might not see it, but anything else you will. So fire barriers, 1 through 4 hour ratings as well. So we have a little bit broader range. There is, once again, just like firewalls, no requirement for smoke rating. And the same standards that we were talking about a moment ago apply to this type of wall as they will to the others. So one example, a pretty common example that we would see in a place that we would want to use a fire barrier is for occupancy separation. One place that we might want to use a fire barrier is in the case of occupancy separation. If we have, for example, a hotel on the left and a conference center on the right, we know that we are required to have a 1 hour fire rated separation between the two. Some occupancies don't require any kind of fire separation, but in that case, that is a required fire rated separation. It has to be 1 hour. That separation between occupancies is a fire barrier as well. So we'd have to use a fire barrier in that case. In this case, a 1 hour separation. Here's another example. We might want to construct shafts. If you're going up at all, you're going to have shafts of some type. So obviously you're going to have stairs. You're almost certainly going to have elevators. You could have HVAC trunk lines or any number of things that you could be running vertically through a building. If they're required to be in a rated shaft, and most of them will be, you're going to construct them once again out of fire barriers as well. Horizontal exits, that's another application in which you would use a fire barrier. If you use a fire barrier for a horizontal exit, the reason you are doing that is so that you can shorten your travel distance, because the point at which that green line passes through that red line, that's the point of exit for the area on the left, and the area on the right would be exiting through that same point. So your travel distance is shortened. That's one reason you do it. You could have multiple doors through that fire barrier, and that would increase your egress width. So if you have a higher capacity or higher occupancy count, then you can get those people through multiple doors instead of the single door into the interior exit stairway. Exit passageways. If you have an interior stair that you need to have protection all the way to the point of exit discharge, which is basically the door out of the building, then you might be required to have an exit passageway. And you would do something like this. That's a dedicated corridor, basically an extension of the stair to get people out of the building. Let's talk about fire partitions for a moment. You can see fire partitions in half-hour ratings and 1 hour ratings. In terms of the wall type or the assembly you'd use is probably going to be a 1 hour. But in the charts in the code, they're going to give you those two. Now, for the first of these walls, we're seeing a requirement for smoke resistance. Even though this is not a particularly tricky thing with regard to construction of the wall, it becomes very important when it comes to construction of the opening. Most of that derives from this chart. Chapter 10 has this table. It's migrated a little bit in the various subsections through the generations of the code. Currently it's in 1020.2. It was in 1020.1 in earlier versions of the code. With regard to sprinklered buildings, which is virtually everything that we do, the highlighted lines, the highlighted rows on here indicate the type of occupancies that require fire-rated corridors. Now, fire-rated corridor in section 1020 is going to tell you that has to be constructed with fire partitions. So for the first time, we see a use for fire partitions. We've been looking at fire barriers, but fire partitions are what are used here. They're still 1 hour, and we see plenty of 1 hour fire barriers. So if you ask yourself the question of why would you use a fire partition, it's because it's smoke rated. The other thing that it brings along with it is a different type of opening. So that's an important factor too. We'll talk about openings in a moment. But those are the principal occupancies. You likely won't see too many hazardous occupancies. But residential, you're going to see all day long. And I-1 and I-3, of course, are senior living and jails, respectively. And so those are required. Now, most of these occupancy types as well are not required to even be constructed unsprinkled anyway. So we're doing a lot more fire rated walls. And usually each generation of the code is going to slide another occupancy type in here that requires fire rated corridors. Be cautious in certain jurisdictions because certain areas like New York City, for example, will heavily modify this chart. State of California modifies this chart, but this is straight from the IBC. So when would you use fire partitions? So here's an example. Any one of those occupancies, this is derived directly from that chart. Any one of those occupancies are required to have walls constructed with fire partitions. That's pretty easy, but again, penetrations through that wall then require an opening pursuant to the requirements for a fire partition. So basically any hole you poke in that wall, put a door in it, or any other things, you're going to need to smoke protect as well. So this becomes is one of my pitfalls. This becomes an often overlooked circumstance. It's easy to visualize this as, for example, a hotel. And you'll see maybe 10 rooms on either side of that corridor, and you'll see 10 doors going down the hallway. We know intuitively those have to be doors that have 20-minute rating and a smoke rating is required for fire partitions. But if there's anything else on the other side of that wall, and you are penetrating that fire partition to get to it, that door also needs the same rating. So, for example, one condition would be an elevator lobby. So if you look at that elevator lobby right there in the center of the building, you're going to see that you're going to realize that normally they have to be smoke rated only. In this case, with a corridor that's required to be bound by fire partitions that are 1 hour rated, that opening has to be 1 hour or has to provide an opening for a 1 hour fire partition. In this case, a 20-minute opening. So even though the elevator lobby doesn't require it, the corridor does require it by virtue of being bound by fire partitions. If you get into the unsprinkled buildings, this is something we could really gloss over pretty quickly because we don't see too many of these anymore. I'll deal with several hundred buildings a year, and I will see maybe one a year. Generally, it's a renovation. But if you do have an unsprinkled building and you are in a building type that requires an elevator lobby, that lobby is required to be fire rated, not smoke rated in an unsprinkled building. So not very common, not likely to see it, but it is in the code still. And just as an aside, the code is written with the presumption that you have an unsprinkled building. And then they go in and say, but if you sprinkler, you can do this and you can do that. And they give you all these options for sprinkled buildings. But the base premise is an unsprinkled building still in the code, still today. So let's talk about smoke barriers. So smoke barriers, just like a lot of the other walls that we've been talking about, 1 hour rating. Smoke barriers is a 1 hour rating. Okay, it's smoke rated, it's fire rated at the same time, just like fire partitions. So why do we have these if we already have fire partitions? What's the point of that? It's the application. So what you'll see different uses for smoke barriers, and the code is very particular about where these occur. Let's give you a couple examples. So they are common in hospitals, for example. In a hospital, you have to break up every floor that serves patients into multiple smoke compartments. You have to have at least two, and each smoke compartment is at least 22,500 square feet. Now, there are variances on that in the International Building Code, so you can drop down as low as 12,500 square feet, but the Life Safety Code still is on 22,500 square feet. So that's really where we stay with regard to smoke compartments, but they are separated by smoke barriers. And in fact, in the code, when they talk about smoke compartments, it's not even a smoke compartment section. It's a section titled smoke barriers. And then they say how in hospitals, smoke barriers are used to separate the smoke compartments. So it's almost as if the smoke compartments follow and the smoke barriers lead. But the critical wall type is smoke barriers. Fire service access elevator lobbies. If you have a building with an occupied floor equal to or greater than 120 feet above the lowest level of fire department vehicular access, you have to have a fire service access elevator lobby. Well, what is it? Looks like an elevator lobby to me, but it has some special considerations. It can serve as a normal elevator lobby, for sure, but it has to have immediate proximity to a stair, has to have immediate proximity, obviously, to an elevator. You have to be able to access it directly off the corridor, and it has to have some minimum dimensions and some other things, but be alert to these, because if you go to this, that is a smoke barrier separating it, not a smoke partition, not a fire partition. And when we get into doors, I'll bring this up right now because it's important. Normally, every door in the code that I've ever seen through a smoke barrier is a 20-minute fire rated door with an S label. At the entry to a fire service access elevator lobby, the code makes an exception and requires a 45-minute door. So just be alert to that because that is a unique application. There are other criteria that apply to that, but that is the kind of the big picture. Smoke partitions, last of our 5. This is the only one of the group that is not fire rated. However, it is smoke rated. So any opening through there is going to have to carry a smoke rating. So a door, for example, you can provide a 20-minute fire rated door with a smoke label. We don't care that it's 20 minutes, but you likely can only get a 20. You will have to have, in most cases with side hinge doors, you will have a fire rating anyway. But in smoke partitions, we don't care about that. What we care about is the S label. So no fire involvement in that case, but smoke certainly. So where are you going to see those? Wall construction in hospitals. That's the main location. There are other occupancy types that require that as well, but hospitals are the big one. Just like with fire partitions, however, if you have an opening into an elevator that is not otherwise required to have smoke protection in front of it and it opens into the corridor, it's going to have smoke protection now because it punches through a smoke partition, and every opening in the smoke partition is required to be smoke rated. Normally in sprinkler buildings, you are going to have an elevator lobby if certain criteria is triggered. And if that's the case, then that's just a smoke rated elevator lobby, again, constructed with smoke partitions. Very, very common. This, in retrospect, in looking back about the projects that I've looked at over the last dozen years, I would have to say that this might be the most important section in the entire code. We've had a lot of people that I've worked with, a lot of people that I've listened to have used terminology such as the more restrictive of 2 requirements governs. That is demonstrably incorrect and kind of a dangerous way to say it because it eludes you into thinking that it's this versus that. You pick one. Or the code says, this one's more important in this case. This is more restrictive. So this is what we do. We're not going to worry about the other. Well, this section of the code, which has been in there for generations, says exactly the opposite. And this is very, very important. Basically, after having gone through some of those wall types, if we have a corridor that's required to be bound by smoke partitions, shown in blue, and that corridor is only smoke rated, that is not a fire rated corridor. Yet it's adjacent to a shaft or perhaps some kind of a space that's required to be bound by fire barriers. Now, fire barriers aren't smoke rated. But fire barriers, let's say in this case, are 2-hour fire rated. So here's the question. The area that's dashed in that that dashed square rectangle, what is the requirement for that segment of wall? So thinking about it, we need to provide all the requirements for the corridor, which is smoke rated. We need to provide the requirements for the area enclosed with the red walls, which are fire barriers, which are 2-hour fire rated. So what does that residual combination wall need to be? Both. It is not the more restrictive governs, it's both govern. So that section of wall is going to have to be 2-hour fire rated plus smoke rated. Now, if we're scratching our heads thinking, wow, well, this isn't good. This is going to cause me all kinds of problems. It really doesn't very often. Now, the only time it really causes difficulty, and it's minor difficulty, is when you have an opening through that wall. So we know that we have an opening through that wall has to conform with the requirements for an opening in a 2-hour wall. Commonly, that's going to be a 90-minute door. And it's also going to have an S label. So not a big mountain to climb, but it is important to understand that that is a combined requirement because of the section for multiple use fire assemblies. Let's talk about the standards that apply in for various walls and for various openings. So the first blocked in section up there are 2 standards that apply to walls. And again, NFPA 263 is incorrect. It's actually UL 263. But those are the standards that apply. They're basically analogous to ASTM E119. But they affect wall slabs, columns, different types of slabs, roof slabs, floor slabs, load-bearing and non-load-bearing walls, 5 basic elements. And that's the wall, the structural element of the building itself, not the openings. The last ones are for openings. So there's a whole bunch of alphabet soup right there. Let's just go through them kind of briefly. UL10B is for doors. typically overhead coiling steel doors. That's where its genesis was. UL10C, most commonly for side hinge doors. Now you can see various doors, like a overhead coiling steel door might have a UL10C listing. So you can see that as long as it's tested to that standard and it's awarded that listing, it's perfectly viable. But most cases in the code, you're going to see a section saying it has to comply with UL10B, and it has some details after that. And then the next paragraph will say, or it can be UL10C and have details after that. NFPA 252 is basically a restatement of UL10C. UL10B, by the way, is much older than UL10C. And I think UL10B was from, I believe, 1942, 1946, somewhere around World War II. So it's been around a long, long time. UL10D is a very new one. That just came to fruition in 2015. And it is basically a test that was devised for fabric fire curtains. So it currently has no place in the code. There is no place in the code that says, this is where you use this. It's defined in the code, but that's it. To go back to something I should have mentioned earlier, any code references that we have in here are relevant to the 2024 code. So if there's anything egregiously different, I'll point that out. That's maybe different in 21 or 18 or before that. UL 1784 is the means of testing for leakage. It's the smoke test, as it were, but the criteria for failure or passage of that is in the code. So if on your door schedule, you note something that's UL 1784, technically, you would have to note what the limits of leakage would be on that, because UL 1784 is only the test standard, not the actual criteria. The criteria is in the code. Conversely, you can't just talk about the leakage allowable, because to what criteria of testing is that? So really the best way to put that on a door schedule is an S label. That's the most effective, because that marries the criteria of UL 1784 with the criteria for leakage in the code itself. And then there's NFPA 288. NFPA 288 you won't run into very often. It is a very, very specific standard, and it applies to floor hatches and roof hatches. It's important to talk about it, though, because you'll see some analogies and some other things, but these are all of the opening standards here for these. Now, there's one other thing we need to talk about as well before we leave the slide, and that is, well, where do they apply? Some of these apply to horizontal systems, some of these apply to vertical systems, and some of them apply to both. So before we completely dismiss UL10D, even though it doesn't have a home in the code, it is tested in both the horizontal and vertical plane. UL10B, UL10C, and NFPA 252 are not. They are only for doors and vertical walls. Now, I hate to have to call it a vertical wall, because that should be fairly intuitive, but we will see people misinterpret that, and we will see people in our industry that will apply UL10B to a horizontal plane, and it has no home there. And if you read the scope statement in UL10B, it's very clear. One other element of that is we're going to talk about in greater depth in a moment, but that is the hose stream test. I won't get too into that yet. We'll talk about that in just a moment, but it does not apply in any way to a horizontal surface, only applies to a vertical surface. So that's important to talk about, but we'll get there in a moment. We'll talk a little more detail on that. So all of these standards are related to one another. They all have common lineage. They have common components. They combine them in different ways. They apply to different things. But there is something called a time temperature curve, and that's in IBC language. And NFPA, just to be different, they call it the temperature time curve. But it's the same thing. It's the same temperatures. It's the same listing. All it is telling you that if you're testing something in a fire endurance test, which is the next sentence, that it has to be at a certain temperature by a certain period of time into the test. We'll look at that in a moment. Fire endurance test is just the fire test. Now, notice we're calling that a test. That is within a standard. So we'll talk about standards, like UL10B is a standard. Within UL10B, there is a fire endurance test. Within UL10B, there is also a hose stream test, separate test within the standard. So that standard has two separate tests. Fire endurance tests, they can vary a little bit, but only a little bit. We'll show you a couple pictures of those in a sec. Hose stream test, it either is or isn't, but it only applies to vertical elements such as doors. It does not apply to horizontal elements. There is a separate description of the hose stream tests, and if you read that, it will mention nothing about applying it vertically onto a horizontal surface. It only defines it applied horizontally onto a vertical surface. That test that's separate for a host stream is generally incorporated into as part of UL10B, UL10C, and FPA 253, those tests. So you'll see it within there. Ironically, you will not see it in NFPA 288. Why? Because floor and roof hatches are in horizontal planes, and there is no host stream test for that. This is the time temperature curve. And it says, if you look at the chart on the right first, it said that after 5 minutes, the furnace has to be at 1,000 degrees Fahrenheit. After 55 minutes, it had to be at 1681 degrees Fahrenheit. And by the time you get to your 2-hour test, if it's a 2-hour test, you need to be at 1,850 degrees Fahrenheit. So this applies a standard to all of our various testing standards. So that we're doing it the same way. We're not wandering all over the map. In other words, we don't have a furnace that sits there at 1,000 degrees for an hour and 55 minutes, then suddenly ramps up to 1,850 at the end. We have a very consistent, reliable, predictable means of testing these. And the actual curve is just how you graph that out on the left. So in reality, the furnace gets up to temperature very, very quickly. But you will notice that if you have a 45-minute door, and that 45-minute door only has to be tested for a period of 45 minutes, it'll only get to 1,638 degrees. So it's pretty much up there right away. These are two separate photographs, obviously, of two separate tests that are very, very closely related. On the left is a neutral pressure test. This is a UL10B test. On the right is a UL10C or a UL10D test. Those use positive pressure. So the furnace temperature is exactly the same in both of them. You will see that it's applying the same amount of heat to the doors. The heat transmits directly through. Neither steel nor fabric will stop it. It still radiates through. And that is fine for an opening. It is not fine for a wall. So we will permit heat to transmit through doors. We will not permit heat to transfer through a wall. So that is one of the other limiting requirements in ASTM E119. But as you can see, they're basically the same. If you look carefully at the picture on the right, you can see that it's bowing outward just a little bit at about 60% off the floor. That's the positive pressure having an effect on the curtain. So the concept is that there is a lateral load placed on the curtain while it is being heated, as opposed to UL10B where that is not done. The end result is kind of a minimal change. Temperature is the same. Duration is the same. That's the only subtle difference. Depending on the test, you may or may not have a hose stream test. Generally, you do. You will not see this in any test that is a 20-minute test. It only kicks in at 45 minutes. So it looks like it's just randomly blasting there, but what he is following a very specific pattern that is snaking across that curtain. And he'll do it a couple times. He'll go across and downward, and then across and sideways. So it's a very specific pattern that they follow. You'll notice, again, this is a host stream applied to a vertical device. And this has to be started within 3 minutes of the termination of the fire endurance test. So you're generally working with a very, very hot specimen in there. Okay, let's go back to our walls, and we're going to talk about the openings in these walls. The walls, we kind of have a feel for it. Where do we use them? What's the criteria for them? But we're going to talk about what the openings are. So in firewalls and fire barriers, you'll see a lot of similarities. But in firewalls, again, separate buildings into multiple buildings. You are limited to 156 square feet per opening. However, you will almost never see this applied because it's waived for sprinkler buildings. So that rarely kicks in, but it's important to mention that in case you do get into an unsprinkled building. Size limit of the openings. You can't exceed 25% of the wall length. That's kind of a hard and fast rule. There is one exception for one application, but that is for interior exit stairways. In other cases, that 25% rules, and you can't exceed that. So if you do exceed that, there is a way that you can, and that is by using an opening that is tested as a wall. Very rare. Very rare can you get away with that. There are a lot of limitations on that. But there is one device that I know of that will do that, but there are some limitations, and you have some other things you have to do to accommodate that. Fire endurance test, it will be 1 hour, 1.5, 3 hours for firewalls. And then you have standards. Actually, there is a 4-hour in firewall that's not on there. The standards that you have to apply, UL10B, NFPA 252, or UL10C. The smoke standard there is no smoke standard because it's not required to have a smoke standard because you don't have smoke rated openings or a smoke rated wall. All we're worried about is fire here. And so with the openings, just keep in mind those standards that you'll have to apply. So let's look at a wall. Let's say it's 100 feet long. We want to put that opening in there. Great, we can do that. It's 14 feet wide, right? So we have a 100-foot wall. That's only 14% of the wall. So, and if you are worried about the square footage in an unsprinkled building, well, there you have your square footage too. We're okay on that. We're just below. But the important thing to note is 156 square feet is per opening, and the 25% is an aggregate of all openings. So what if we want to put another opening in there? Can we do that? We can't. Why? Because two 14-foot openings in a 100-foot wall is 28 feet. That exceeds 25%. We can put an opening there. We can't put that big an opening there. So now where are we? We're 14 feet wide plus 6 feet wide. We're 20 feet wide. It's 20% of the wall. We are fine with this. So we can do this. But we can't have two big overhead steel doors in this wall. Okay, now we're going to do fire barriers. What do we do with fire barriers? Okay, this is very similar to firewalls. You'll notice if you look at the walls or the opening types, and I'd mentioned on the other slide that it went up to 3 hour. We were talking about doors, so that 3 hour was correct. This 3 hours, the top is the most extreme opening in a fire barrier. You will find that in a 4 hour fire barrier, which is also very rare. But this is very, very similar. Again, limitation to 25% of the wall length is there as well. And then the standards that applied are exactly the same, and there is no smoke standard. So openings and fire barriers, openings and firewalls are very, very similar. Let's look at the same wall, or basically the same wall. Let's look at a 100-foot wall, and now we have a 14 by 12 opening. It's 168 square feet. Can you do that in an unsprinklered building? Well, you don't have to crunch the numbers because I already did that. 168 square feet. Even doing math in my head, I think that's more than 156. So no is the answer in an unsprinkled building. In a sprinklered building, however, that's waived. So yes, you can do this. And we're in the same situation as we were a moment ago with the firewall. We have 14% of our potential openings used up. And if we want more openings, we can do that. But again, we have to do that, but it has to be a smaller opening, just like in the firewall itself. Openings and fire partitions. Okay, now we're going to change the game a little bit. Size limit, either area per opening or percentage of the wall, off the table. Doesn't apply. So we can do whatever we want in terms of size of the wall. Fire endurance in fire partitions is always going to be 20 minutes. So we're in a very, very different category here. Again, it's important to understand, this probably illustrates why better than anything else. It's important to understand what type of wall you are applying. Again, you can look at a 1 hour wall and note it on your drawings as a 1 hour wall, but is that a fire partition or is that a smoke barrier? Or is it a fire barrier? What is it? The best thing to do is to note on your drawings that this is a 1 hour fire partition. That way, it leads you into remaining coordinated with your opening types. Otherwise, there's no way to tell from that note that your door openings coordinate with that opening type. So an AHJ doesn't have any criteria to judge whether or not that you are correct or incorrect on that. So fire endurance, 20 minutes. Now we have a smoke standard in there too. So we have our same fire standards. And again, they're exactly the same as before. They're just not 90 minutes and 45 minutes and all that. Now we're only at 20 minutes. It's the exact same test. However, they omit the hose stream test from the 20-minute test. It's just not relevant. So it doesn't apply in here. But it is absolutely correct to say that the door required in that 1 hour fire partition is a 20-minute UL 10B opening protective tested to UL 1784, or alternatively with an S label. So let's take that same wall, 100-foot wall. Visualize a building section through a hotel. Now you can easily see this on one floor. You just see a whole bunch of rooms there. They're all a bunch of 3-foot wide doors. If this was a fire barrier, how many doors are there? It looks like 9. 9 times 3, we have 27 doors. That would be 27% of that wall. Couldn't do it if it was a fire barrier. Can do it if it's a fire partition. Be mindful if you have part of that wall, if for whatever reason is required to be a fire barrier, the fire barrier limitations apply to that section of wall as well because of multiple use fire assemblies. You're not going to see that much. You'll see that in stairs where they open up there. But also, all of these doors are also required to have an S label. So they have to comply with UL 1784, tested to the standards in the IBC. Again, the easy way to do this, the most comprehensively correct way to do this is in the door schedule to actually just write S label, because that covers both your grounds. And by the way, that is defined in the code. Okay, let's switch from fire barriers or fire partitions, excuse me, to smoke barriers. Well, we're kind of similar. There are no limits on this one either. The fire endurance is still 20 minutes. There is one exception. If you look at the openings in some of the tables of the required rating for a door in a fire partition or in a smoke barrier, I'm sorry, you will only see 20-minute on there. That 45-minute exception is only in the subsection for fire service access elevator lobbies. So be very careful about that. We'll talk about that again in a moment. But the standards that applied are the same standards we've been applying for fire. Smoke, UL 1784, same as a fire partition. So these are very similar to fire partitions, but it's important to understand that something's a smoke barrier or something is a fire partition, and it clarifies it if you put that on the drawings as that type of wall, because then the HJ knows what to look for, or you internally know what to check for. So if you have a 100-foot wall and you want a 90-foot wide opening, have at it. You can do that. It has to be smoke rated, but you can have that 90-foot opening. You can have a 99-foot opening. In theory, you could have a 100-foot opening for that matter, because there is no limit. It doesn't say limited to 99%. It says no limit at all. So that's an example of a smoke barrier. Now, a common application for this, we didn't talk about this earlier in one of those applications, but if you walk into a hospital and you have a 2-story space and you look up and you see somebody standing at the guardrail looking down at you, they can do that. However, they are standing in a separate smoke compartment than you're in on the first floor. So what do you have to do? Well, remember, we said smoke compartments are separated by smoke barriers. So there could be a deployable opening in a smoke barrier right at that guardrail line. And in fact, there has to be. There has to be something that closes that off, because you can't connect your smoke compartments. Regardless of whether it's an atrium or not, let's assume it's not an atrium, and it still has to comply with the requirement for separation of smoke barriers. Now, a hospital, a 2-story space is an atrium, so that's a different issue, but we're not going to get into that right now. So that's the requirement for smoke barriers. We have one more to go. Smoke partitions. So kind of no limitations on this. There's nothing on this. There's no fire on this. All that you're required to have is a smoke rated opening. So if you use a smoke partition and you put a 45-minute door with an S label on it, that's fine. You can do that. You've gone over and above. There's no requirement for fire rating. It doesn't say you can't do it. But what you do need is that S label. Let's look back at our 100-foot wall that we've been looking at the whole time. I use that so the math is easy. An opening in a smoke partition, very, very similar to the smoke barrier. It can be 90 feet wide. It can be 99 feet, 11.5 inches wide if you want. It can be 100 feet wide if you want. So there's no limit on that. However, you do have to have an S label on that. So if you use a generously wide, let's say a coiling fabric curtain in this case, because you often see them this wide, what do you have to have? Fire rating? No, you don't need any fire rating if it's an opening in a smoke partition. But you do have to have that S label. What if you have a wall? We've been talking about openings. We haven't gotten as into the applications that much yet. We're going to look at that in greater depth. But what if you have an expansion joint? We do those all the time. We don't think much about it. But an expansion joint in there, we have an expansion joint cover, we're off to the races. If there's no rating involved in that photograph, we're done. It's easy. We have to do it because there's always movement in buildings. Sometimes you get seismic that's going to move buildings around, and you have to do it there as well. So this is not a complication until you get into rated walls. And what happens when you get into a rated wall? Well, this doesn't directly correlate to that photograph, but you could have a condition such as this. The expansion joint is easy. It's just like the expansion joint in the non-rated wall on the other side of the building that we just did a little while ago. But this one is rated. So what do we have to do here? Well, we have to provide some kind of fire separation. So basically what we have is 2 rated assemblies, and we are adding that fire separation in there. You can get this through most any expansion joint cover manufacturer. They manufacture these as well. And they can be sent out as a package. Let's take some examples. So we'll do some what ifs. What if you're presented with this project? You already have this existing building. It's a business occupancy. It's, I don't know, it doesn't matter. Let's say it's a dozen stories tall. And it's been around for a couple of years. It's all established. It's fine. The egress is fine. Everything's working. There's no glaring code issue in this to begin with. For business occupancy, with this floor plate, it's something over 13,000 square feet gross. If you calculate out the occupancy for a business, or the occupancy count for a business occupancy, it's for 150 square feet gross per occupant, which means you have 89 occupants on this floor. So whether you have 97 or whether you have 42, it doesn't matter. The code says you have a maximum of 89. So that's what they base the door widths on, for example. So in terms of egress, you're going to have 0.2 inches per occupant, or giving you 18 inches of total door width. Well, you've got that whichever way you're going in this. And so we are fine on that building. But what if we wanted to change that to a restaurant? So we have this 12-story office building. We want to put a restaurant on the 6th floor to serve that building. And we can do that. And in fact, an architect came to me not too long ago with this exact floor plan to do exactly that. But when you change to assembly, your occupancy goes up. The assembly count for occupancy is 15 net. So now all of a sudden we have a little bit less square footage with the assembly occupancy, because we calculated on net square footage, not gross. But so we're only at 11,350, but it is 15 people per square foot, or 15 net square feet per person. So that gives you 757, might as well be 1 million occupants. That's a lot of people. So just by changing the occupancy type, we have skyrocketed our occupancy count, and we have completely overwhelmed our existing means of egress. So what do you do? That was a big, long description of why you might want to do this certain thing. So we need 152 inches of door width. Well, we don't have it. What do you do? Well, you can put a fire barrier in there. This is a horizontal exit. In this case, all horizontal exits are 2-hour fire barriers. So you can put that in there. And now what are we doing? Well, we're egressing through doors into another safe space. So our egress is not directly into the interior exit stair on the top side of that drawing. It is through those openings from the lower side, through those openings. So that is our alternate means of egress. So we have actually three means of egress. The two really principal broad means of egress is one into the interior exit stairway. The second is through the horizontal exit to a safe space. So you can do this to cut down your square footage. Now, once we cut down our square footage, we've cut it down to 5,675 square feet net. I ran that wall right through that little island on the right. We're going to pretend we don't see that, although I have seen that in real life. We're going to so we cut our square footage roughly in half. So we're down to 5,675 square feet net. And again, our net factor is 15. So that means we have 379 occupants. That's better, because if you do the calculation then for your total door width, it's only 76 inches. So now we're in much, much better position, and we have a horizontal exit through which we can exit. So that makes life much, much easier. So can we do this? If we wanted to do what we see here, can we do this? We want to have a 23% opening on the left, taking up basically that entire bay, column to column. And then we have another door over there, close to that island. Can we do this? Well, 23 plus 5, and is 28% of that overall wall. We've now exceeded the limit for fire barriers. If you remember that was 25%. So we can't do this. We can get sort of close. Let's get a little bit below that threshold, make sure we're safe. So we can do this. Now we're at 23%. So we are fine now. So we can do this. This is a viable solution using a horizontal exit, which is constructed with a 2-hour fire barrier to egress either half of that floor plate to the other half. So a different application. We're not going to talk about horizontal exit here, but let's talk about other applications involving some of our rated walls and maintaining openings on our rated walls, and us getting into trouble on egress. Now, we did touch on egress, obviously, with the horizontal exits. Always be alert to egress, because you might think you have a problem solved and you've left yourself with an egress problem. In this project, that's potentially what happened, even though I can't claim to know what the egress path is. If the egress path is what I think, we have fire barriers here, and we have smoke partitions there. So we have a high-rise building. We have smoke partitions creating an elevator lobby. We have rated walls around our shafts for our elevators. And what happens if we want to egress from the lower portion of that building? And what if that egress path goes through that lobby? Can you do that? Well, if you look at that for a moment, you'll say, well, let's see, the top doors. Yeah, I'm going through those doors. They're fine. But the bottom doors, well, wait a second. Those doors are swinging against the direction of travel. I can't do that. And if you flip the equation and you're on the upper part and you want to egress down to the lower part, you can't do that either. So as long as the egress path does not go through this lobby, you can do this. But if the egress path goes through the lobby, no, I see this a lot. What could we do? How can we fix that? Well, we could do this. So we could have double egress doors that go either way. The problem with something like this is that you now have taken up a lot of space. If you have those 3-foot leaves, they're going 3 feet in either direction. Now you could extend into the hallway a little bit, but you can't extend that far in front of an elevator door. So we're getting in the way of our elevator doors, and somebody has to be able to egress from that elevator into the lobby. There's another lobby. There's another little trick for you. What happens here? Now, this is I apologize for the terrible drawing, but it will serve its purpose. This is actually the office of a very prominent architect. So one that we've all heard of, and I don't really care what part of the country you're from, you've still heard of them. So they had to create an elevator lobby. I don't remember what floor this is, but they're a good bit elevated in a high-rise building, and they had to have an elevator lobby. And they had to construct those with smoke partitions. So the first step, what do you do with the rated walls? Well, you basically have this. You'll have a little more on the bottom because I didn't show them around the stair, and obviously they're there. But in terms of just talking about this lobby area, we have this configuration of rated walls. So we have the openings from the elevator opening into the lobby. That's fine. It's an opening through a fire barrier. And then we've constrained that elevator lobby with smoke rated construction by using smoke partitions according to the code. So this is fine. This is pretty easy. To get around that whole issue with the swing doors that we were looking at in the last one little benefit we have on this drawing is that they have shown us where the exit signs are. So this is what we know our exit path to be. Are the exit signs? We're not going through that elevator lobby. We're going either direction. Now, if they made a mistake and had to egress through that elevator lobby, they made another mistake by not putting an egress or an exit door above that door. However, they did that on the other end of the lobby, so I doubt that's the case. And I know this architectural firm, they don't make elemental mistakes like that. So this is basically your egress path. Now remember, you have to get people out of the lobby because they could be trapped in there when these doors deploy. So you have to get them out. So that door over by the exit sign on the right has to have a capacity for egress. Now we can talk about egress. We could do that for about 2 or 3 more hours. We're gonna defer that to a different class, but that does have to have egress there. So those exercises are telling us that that egress is not through the lobby. The one thing we will mention about egress from the lobby is that what is your occupancy count in that lobby? As a business occupancy, it's 150 square feet gross. It's probably somewhere in the neighborhood of 300, 325 square feet. You got 2 people in that lobby, maybe 3. So your capacity for egress is only a couple of people. So that changes what you need to do. Again, if you got over 50, not plausible, but if that was an assembly lobby, it wouldn't have to get too much bigger in order to hit that threshold. Then our doors dramatically change. So what do you do in a case like this? Now we're really getting into splitting hairs because now that you are all experts on doors and continuity of ratings and openings, if this is a smoke rated curtain in blue and the side guide is embedded in a fire rated wall shown in red, what do you do? Well, this is what we're looking at. The generic shaft wall, this is what that red wall is. This is a 2-hour because of the 2 layers of 5/8 inch type X that you see on the lower portion or the near portion of that wall. And now we want to put that door in there that we saw. Now remember, this is a smoke rated door. So we want to put that in there. Okay, we've done that. Don't you wish detailing was always that easy? We put that in there, but this is only a smoke rated system. So what have we done? Now we know that we can put electrical boxes in a fire rated wall, and we can put non-rated electrical boxes in a rated wall, provided they meet certain criteria such as size and material. But what about this? There is nothing in the code that directly addresses whether this is compliant or not. So remember, this is only a smoke rated system that we're putting in here. We're embedding a smoke rated side guide into a fire rated wall. What is that? Basically, if it's not fire rated, It's a hole in that wall. It's a membrane penetration. So this is not in the building code directly, but you do see other elements that are parallel to this. You see it with electrical. I won't even go so far as to make this a recommendation, but I would suggest that you might want to look at the construction of that side guide and see if that system is in fact fire rated or just smoke rated. A lot of manufacturers will have a smoke rated version of a side guide and a fire rated version of the same exact curtain system, including the side guide. Are those systems the same? Are those side guides the same? Well, in many cases, that will then have been tested as a fire rated side guide, even though it's not labeled as such. Kind of a gap in the code, something that's not really addressed, but something that's important to look at. So hopefully we've learned everything there is to know about rated walls. Well, maybe not everything, but a lot of things. So we know what the 5 basic wall types are. They are not all fire rated. They are not all smoke rated. Some are either, and some are both. We talked about what are the applications for those. Where do we use these walls? We learned about the limitations of openings. This is a big one. Remember, fire barriers are limited to 25% of the wall. There is one exception, and that's only for interior exit stairways. I say one exception to the 25% limitation. You can't exceed 25% alternately if you have that system tested as a wall. But that is very difficult to do. We talked about different little pitfalls you can fall into, some that are common, some that are obvious, some that many of us make all the time. And we look at it afterwards saying, oh, no, I didn't do that again, did I? Well, yeah, we did. Some of these are easy to make. We go back and we fix them. Watch your door schedule. Make sure that your terminology is correct. It's easier to use an S label than it is to use UL 1784 testing because UL 1784 only tells half the story. Watch out for fire service access elevator lobbies. Their doors are 45-minute smoke and fire rated doors. I didn't mention one other thing, that smoke rating is tested without an artificial bottom seal. Different topic for a different day. But look carefully at that opening because it is unique in the building code. And then we see other kinds of outside the box type conditions, such as that side guide embedded in a shaft wall. Look out for some of these things, but it pays to know what kind of wall that you're looking at. I hope this has been helpful and look forward to talking to you soon.
This concludes our AIA Continuing Education On-Demand presentation. On behalf of SmokeGuard and the EBS Group, thank you for your time and attention. As a reminder, you'll need to complete a 10-question test to receive credit for this course. Simply click the test button below to get started. After completing and passing the test, you will receive your AIA Certificate of Completion by email to the address you provided before taking the test. If you're an AIA member and you provided your member number, we'll submit your credit directly to AIA on your behalf. Please allow up to 10 business days for your credit to appear on your AIA transcript. To recap, SmokeGuard's core offerings include standard and custom elevator smoke containment solutions and vertical, horizontal, and perimeter fire and smoke curtains. If you would like information on any of our products, design support, or additional AIA presentations, you can contact our support team or visit our website. Additionally, the EBS Group offers AIA-approved courses on life safety products. Balco covers expansion joints, photoluminescent egress systems, and fire stopping. SmokeGuard focuses on fire and smoke protection solutions, and Greco offers courses on commercial architectural railings and code compliance. Scan the QR codes or visit their websites to explore all available courses. If you have any questions or would like more information on SmokeGuard, visit our website at www.smokeguard.com. Thank you again for your time and interest. We look forward to seeing you on our next AIA On Demand video presentation.